I'm going to be adding a bidet to one of my toilets, or a bidet seat. And this seat requires power to, heat the water, etc. So what I'm going to be doing is extending one of the outlets in my bathroom, and I'm going to show you the process of cutting open some drywall, running some new Romex, extending your existing outlet, and installing a new receptacle. The way my house is wired is the outlets in my bathroom are GFCI protected. They are protected via a GFCI breaker. So what I have in my bathroom are just standard receptacles. However, you might have GFCI receptacles if you're not using a GFCI breaker. Whether you have a GFCI breaker protecting your outlet or a GFCI receptacle, you want to make sure you have GFCI protection when you're installing a outlet that could be exposed to water. So the first thing that we're going to do is shut off power to this circuit. Anytime we're dealing with electricity, we want to cut the power. We do not want to shock ourselves, potentially kill ourselves when doing this project. And then I also have this tool here that I can plug into my outlet just to assert that indeed there is no power at this circuit. Then I'm using a stud finder here to just check for any studs. I actually do not want there to be any studs here for this job. So I'm just making sure that there is no studs that I have to work around here. I just want to run the Romex down through the wall and access it on the other side of the wall. The next thing I want to do is just kind of take some measurements. I want to see like where this outlet is relative to the wall here. And on the other side, do kind of the same thing. Just kind of see like, where do I want the outlet to be? In my house, all the outlets that are near the ground are about 12 inches from the floor. So I'm just kind of measuring from the floor to get it about that height, and just making sure that the distance from the wall is pretty much the same as it is on the other side of this wall on the existing outlet with the vanity. And so the dimensions for this box is going to be 2 1/4 inches wide by 3 3/4 inches high. That's going to be the rectangle that I'm going to trace with a pencil. So I'm kind of just using the level here as a straight edge, and also just to make sure that my lines are level, that they are perfectly flat to the ground and perfectly parallel to the wall. So I'm just making sure I get a nice clean trace that I can cut. Once you've got the trace, then comes the part that was a little bit scary for me when I first did this. I'm using a jab saw here and just going to start cutting into the drywall. And the name of the game here is patience. And you really don't need to rush this step. You can just kind of take your time and do very slow and controlled movements with a saw. And I will say this part is definitely kind of laborious. I was sweating when going through cutting this. So once it's cut out, then the rectangle of drywall should just come right out. And then I'm just going to stick the new electrical box into the hole and make sure that it fits. And I'm not getting it all the way in. I'm just doing a preliminary check to see if I'm going to be able to get this thing in when the time comes. We're going to take off the outlet cover on the existing outlet and just unscrew the receptacle and pull it out of the wall gently here. The wires here are running up in the ceiling, the existing wires, which is actually perfect because I'm going to take a hammer to my flathead screwdriver and just knock out another hole in the electrical box there. This is a 15 amp circuit. You'll see the number printed on the breaker. Since it is a 15 amp circuit, we need to get the right kind of Romex. So what we're looking for here is the 14.2 gauge Romex. So I'm going to just start feeding that new Romex down through the wall, and on the other side of the wall, I'm just gonna catch the Romex and then pull it on through the hole that I created. So the next thing I'm gonna do is remove some of the sheathing off of the Romex to access the hot and neutral and copper wires. But I actually recommend feeding the Romex through the new electrical box before you do this. This is kind of like a little mistake I made when recording it. Here, I'm just gonna remove the knockout from the new electrical box. And so here is what I'm going to feed the new wire through. This was a little bit tricky since I removed the Romex first, because I was really worried about like damaging the cable, and the sheathing on the Romex will protect the cable. So again, I recommend just getting the Romex through the knockout first, and then cutting the sheathing once it's through. But didn't really have a problem. My wife ended up helping me kind of pull it through while I was like holding the knockout. I just got to go on the other side here and just kind of pull some of the slack out of the unnecessary cable, and then I'll just kind of push the new electrical box into the wall.
Yeah. There we go. That sounded good.
How's that? Now, the way this electrical box works is they have these 2 screws on each corner of the electrical box, and when you screw those screws in, it basically will have this like fan out situation in the back of the box. So it's going to be kind of like hugging the drywall from the inside of the wall, and so that's going to help keep the electrical box like in place. So that'll hold the box into the wall. So make sure you kind of get it like tight enough where like this box isn't going anywhere. So again, I'm using a standard receptacle, and I'm doing that because I'm installing this on a GFCI circuit. There's a GFCI breaker, but you may have a GFCI receptacle. In that case, I recommend just going to a YouTube video that shows how to wire a GFCI receptacle. All right, so let's go ahead and wire this thing up. So I'm gonna just cut off about 3/4 of an inch of some of this sheathing to expose the wire. And I'm doing that on the hot and neutral wire. The black is the hot and the white is the neutral. And of course the copper is already exposed, so we don't really need to do anything there. And then basically I'm just creating these shepherd hooks, have the wire kind of make a 90-degree U-turn, and that is what we're going to use to hook around these screws or these terminals on either side of this receptacle. I just hook it around and I tighten up these terminals, and once you got it tightened on there, give your wire a little pull and see if it's secure. Like give it a little bit of strength to make sure that it's not going anywhere. The white goes to the silver screws. The hot or the black wire will go to the brass screws or the gold screws. And then the copper wire or the ground wire will connect to this green screw here. Yeah, so you want to get this thing hooked around these terminals on each side of this receptacle, ensuring that the exposed wire that's touching one of the terminals is not also in contact with the terminal that is right next to it. So just make sure it's kind of like fitting in there and snugly. And you also want to really make sure that the hot never comes into direct contact with the neutral bare wire, or the hot doesn't ever come into contact with the copper or the ground wire. You don't want to have that exposed wire making direct contact. Otherwise, it's going to be a problem when you go to turn your power on. So yeah, once you've got them all wired up, once you've made sure that they're all secure and they're in there and they're not going anywhere, when you give them a tug, you just neatly kind of put the outlet in, and you kind of connect the screws into the holes on the top and bottom there, and you just screw it on in. And once you're ready, just put on the outlet cover, get a flathead and just screw it in there. You do want to be pretty careful with the face plates because they do tend to break pretty easily if you over tighten them. So the existing wire, they did not use the approach of hooking the terminal screws and screwing that in. What they did is they put the wires in this connection in the back. So it's like a push-in connection. So I need to remove that. If you stick a little small flathead screwdriver in the little hole that's right next to these wires, you press down a little bit, you'll hear a little click, and then that basically releases that wire so you can pull it out there. And so that's what I'm just doing here, is just pulling out all these existing wires here. So here I'm just taking the Lineman pliers and just cutting off about 8 inches or so from the wall there. And then I'm going to cut off about, let's say 8 inches of Romex. It might be a little too much. You could probably get away with less Romex here. I decided to give myself a little bit of extra kind of breathing room. I'll pay for it later when I'm shoving this thing back into the wall. So essentially what I'm going to do here is I'm going to take the existing wires. You can see that there's 2 blacks and 2 whites that are existing and one copper. And so I'm going to take those existing ones, and then I'm going to take my new one. So there's going to be a new black and a new white. And then I'm going to take this free little like 8-inch piece of Romex here. So I'm going to have like 4 whites or 4 blacks all together. Then I'm going to wire nut those. And then the one that's like the free Romex is the one that I'm going to attach to the terminal. Again, removing about 3/4 of an inch to expose the bare wire on the 14 gauge hot and neutral. And doing the same thing here on the free wire. All right, and so then we got the 4 wires all bunched together, and I'm going to stick my red wire nut. Remember, you got to use the red wire nuts for the 14 gauge wire here. And just give it a little twist up here. And just what we want once we twist this stuff up with the wire nut is we want to give all 4 of those wires a tug, like a firm tug, and make sure that those wires are not going anywhere. We do not want a loose wire in our box. So you can see here I actually didn't get it right. I actually had a loose wire, so it was good that I tested this. 3 of them got braided up in the wire nut, but there was a exposed one, or one that didn't catch. So what you could do here is take your Lineman pliers and just kind of like undo the braid, just kind of like grab them and then just kind of twist it counterclockwise to kind of undo the braid that was created, and then try it again. Put the wires together and try wire nutting them again and making sure that they stick. All right, and so then this time wired them up and gave all 4 of the wires independently a good tug, and they were all stuck into the wire nut. So I felt pretty good about the neutrals. So now we just do the exact same thing with the hot. So just cutting off the ends there to expose the wire, and then take a wire nut and just twist it on up, give it a tug, make sure it's not going anywhere, and you should be good to go. And then finally, we'll do the same kind of principle here for the copper. This time, in my case, I have the new copper from the Romex that I just installed. And then there was 1 piece of copper in the existing box. So I'm just going to join those. So we have like kind of 3 copper wires here. Our circuit is now ready to be wired to the receptacle that was there before. But this time, instead of doing the push-in connections, I'm gonna switch it to using the shepherd's hook. So I'm just gonna take the Lineman pliers and create these shepherd hooks, and then just fasten them to each of these terminals, where the black goes to the gold, the white goes to the silver, and the copper goes to the green terminals. to make sure that everything is kind of wired correctly here. And I should have done this on the new receptacle that I installed, but I especially want to do this here since I have all these wire nuts and whatnot. So I'm just taking a multimeter and setting it to the ohms setting here. I want to make sure that there is no continuity between the hot or the black wire and the white neutral wire. If this ohm meter, the one that I have here it's a fluke, and it creates a sound when there is continuity. It means that there's a complete circuit. We do not want the hot to be touching or be in contact with the neutral, and we also don't want the hot to be in contact with the ground. If you have no continuity between the brass and the ground, or the green one, and you have no continuity between the hot or the brass and the silver, the neutral one, then you should be good. If you touch the neutral and the ground, you should hear an audible sound. There should be continuity there. Now it's just time to figure out how to get all these wires back into this box. In the end, it was okay. I was able to get it all in there and take the screws and screw it back into the wall. We're gonna stick that plate back on. We're gonna turn the power back on at the breaker. We can see that we still have power in our first outlet. That's good. And we can stick it also into the new outlet. It looks like we have power here, and this little device has a button that will test the GFCI for you. It'll like trigger the GFCI to interrupt the circuit. So I'm going to just press that button, and you can see that the power gets cut off there from the indicator light. So we know we're good. We got GFCI protection and we got power to this thing. So we're just about ready to install our bidet. Hope you found this tutorial useful, this demonstration useful. And let me know what you guys think in the comments, and I'll see you in the next one.